Saxon, Algebra 1, Lesson 42. Here we go with a kind of problem that's going to make you feel really smart. Let me show you. (6y minus x plus z). That in my world is a z equals 4. If I just make a z like that, it looks too much like my 2's, which sometimes look like that. I try to make my 2's with a loopy tail, but it doesn't always work. So I make z's with a slashy mark because I don't make a lot of them. And that way you'll notice a no-go. Oh wait, that must be a Z. Okay, this kind of problem usually freaks out the average algebra student. Not that I'm calling you average, but the typical algebra student sees all these letters and freaks out. Somehow, students get this crazy idea along the way that math should be about numbers and not letters. And when we throw letters in, it freaks a lot of students out. And honestly, the more letters, the more freaked out they get, which may or may not be fair. But I'm not here to debate justice at the moment. I'm here to tell you these problems, there's no way to solve a problem unless we get one more piece of information. Thankfully, John provides it to us, so I'm not wasting your time right now. But I want you to notice that there are three different letters in one equation. There's no way you can solve that. The rule for algebra is you have to have, if you're trying to solve multiple variables at a time, you have to have at least one equation for each letter. Okay, so like we have a x, a y, and an x and a z. That's 3 letters. I would have to have 3 different equations that told me different things about these guys. One equation per letter. So this isn't going to do me any good. But John says something magical. He starts it by saying solve for, let me just double check, y. And I always circle that letter because it's very important. This letter drives the whole problem. Now what we know is that we want to get the desired variable alone on one side. That's a lot to write, I'm sorry. It's a lot of letters, right? That's all we can do. We're gonna literally solve the equation for that letter and just shove everything else on the other side. Have you ever done that, like rearranging your bedroom? Oh my God, I loved rearranging my room. And I would always just take everything and shove it in one corner and then start putting the things where I wanted them. That's a lot what these equations are like, except we shove everything in one corner and then we're done. So what we're trying to do is isolate that x, right? So there are quite a few different ways to do that. Right from wrong, there is no such thing. As long as you're working accurately from an algebra point of view, you do it anyway. What I see is, let's send these guys swimming over here, and then we'll just have the 6y by itself. So to both sides, I'm gonna add the x, and then I'm gonna subtract the z. I'm writing those as a stack just because this is in my way. That cancels, and now I get 6y equals, and I'm just gonna bring it down. I'll keep it in this order, 4 plus x minus z. Cool, right? Now I'm gonna divide everybody by 6 because I need to get this y by itself. So I'm going to divide each one of these terms by 6. Beautiful. That reduces. I get y equals, now this I can reduce, right? It's 2/3 plus x over 6. You know, if I wanted, I could write that like this, but that just creates a floaty. And I don't do that unless I'm dealing with linear equations, but that's a different story. Don't worry, I'll tell you about that later. There's one situation in which I will accept a floaty x, but not this one. I don't like a floaty x here, so I'm just leaving that as a fraction like this. And then the same for the z over x. And guess what? That's our final answer. It's not a lot to look at, and some might argue this does not look simplified compared to this. This looks simpler. But what this did do was it got y, it solved this equation for y, right? Because now we know if you wanted to take this and substitute it into something, you just plug it in, right? This would be what you use. Okay, so John has to tell us what letter, and then we just shove everything in the corner of the bedroom, and then the Y is like the bed, right? It's the one thing you want separate and special. I'm just spitballing on that metaphor. Maybe it works, maybe it doesn't. Who knows? Only you know for sure. Okay, but it's kind of like that. It's a new one. I've never used that one before. Okay, we better do another one before I get distracted. We have 5 problems in this lesson, all jamming on this same idea. One thing I want you to get over, and I mentioned it before, is that whole idea that like letters are evil and numbers are safer. That is so not true. A lot of times in these problems, letters are easier because, like, look at this. These letters, they're easy. You don't have to simplify when you have a letter in the denominator or the numerator. It's just that. So don't let the letters scare you. Just remember that John has to tell us which one we're interested in. Okay, moving on. Here we go, second one. John tells us solve for y. What I like to do is write down that letter and circle it over to the side so that I won't forget which letter it is that I want. Again, we can swim the y to either side. We can rearrange things however we like. As long as we're doing the work carefully, it'll all work out fine. But of course, I'd always rather do what looks easiest to me. So I see this y, I go, okay, let's make that the y. Let's bring this y over, because then we only have one thing to fix here, and I'm gonna add the 4. Do you see how I did 2 things at once by thinking carefully about how I wanted the fish to swim? So I'm bringing the y fish this way. I'll take the plain number fish that way. This cancels and this cancels. I wrote everything down, so this is in balance. And now I'm ready to see what I've got. 4x plus 6 equals 3y. Okay, so now same thing, I just have to divide away the coefficient. That's what that's calling. That's best friend go home, right? And so then our final answer is, I don't want an equal sign there, y equals 4x over 3 plus 2. 2 does not have a denominator, but I'm not making him float. I'm writing him up in numerator territory. Right? That's the correct answer. I write this down always because it's so easy to get turned around in these problems because there's just a lot of pieces that I like to write it down so I have it right there if I need it. 42.3. This one we are asked to solve for p, like a popsicle. I don't know why I said that. Ready? 4p, and again with these, right now, don't do anything but just copy it down as it's written. It is dangerous. All right. Once again, I look at the p's and I go, okay, what's going to be easier? This p has 2 things attached to it. This p has 1 thing attached to it. I'm going to move the p's to this side so that I only have 1 thing to get rid of. So I'm going to subtract that 6a, and I'm going to bring the p over this way. Okay, that cancels and that cancels. I get minus 4a plus 5 equals minus 3p. Right, that's a 1 minus 4 would be minus 3. okay? And then last step, best friend, go home. Just have to be careful because I'm dividing by a minus this time. I'll write my answer over here, and I'm gonna bring the P forward. Just like I did here, the Y was on the right, but I popped it over and put it on the left. I like to have the letter that I'm solving for on the left. Even if I work the problem with it on the right, I can just let them trade places at the end. No signs are being changed. We're literally just picking the problem up and flipping it over, if that's a thing you can do. It's kind of like, well, no, never mind. I was gonna say it's like when you finish a puzzle and you try to pick it up and put it back in the box, and sometimes it all sticks together and sometimes it doesn't. But with equations, it always works. Okay, enough with the metaphors. Oh my gosh. 4a over 3, right? The two minuses cancel out, minus 5 over 3. Wait. Did I copy something wrong? Yes, I copied something wrong. That was supposed to be a minus 5. So our answer is correct given the way I wrote the problem here. I'm not going to go back and change it because everything else is right. All the important bits I got right. I just copied it wrong. I'm sorry. I'm sorry. So if you look in the book, you'll see this is plus, but you'll see that is minus. This is okay. If I could draw a really fast and really good thumbs up, I would do it. But I can't, so I'll do that instead. All right? Okay, don't be like me, kids. If I was doing my homework, I'd go back and change that, and then I'd just change it as I went through, and then I'd show it fixed over here. But I don't want to confuse you with a bunch of scratching out, so I'm not going to do it. Call me a rebel. 42.4. Solve for x. Oh, I always feel happiest when I'm solving for x. Ready? I'm going to be extra careful copying, you better believe. That's a plus x. It's kind of squishy. Okay, now John this time chose to shove everything. He already shoved everything in the corner, didn't he? So all we have to do is just move the bed back where we want it. The bed is an x. So there's a plus x, and there's a plus 3x. So together, those make 4x. So we can subtract 4x from both sides. Right? We can also combine these like terms. 5y minus 2y, that's 3y. Okay, so I can cross all of these out because I've bumped them into other things. 4x is going away. It'll end up over here. So now I have the 3y, which is 5 minus 2. And then I will have this stays. That's minus 4 equals minus 4x. Now, one reason I wanted to do this too is I've done this on a couple ones. Don't be afraid of getting a negative coefficient that you're gonna have to divide away. It's perfectly fine. It's perfectly fine. Some students will work like crazy to make sure that their coefficient always stays positive because they're worried about dividing by negative. It's fine. I understand it's sometimes a pain. I try to avoid it because I tend to drop those minus signs, right, when they're just hanging out in the front. But if I'm extra careful, it's all going to be fine. I'm dividing everything by minus 4. That's going to cancel. Oh, look, this is going to become a plus 1. So let's write the answer. Ready? It is x equals, this is going to be a minus 3y over 4. That becomes a plus 1. And I'm writing it denominator-ish because I'm not even going to say it. You know how I feel. Yay! And one more. Here we go. Make sure I copied it right. We're solving for y this time. Okay. Well, we just have the one term with the y in it. And we could move him over here and him over here, but let's just boot these two guys across. Right? That cancels, that cancels. We get 4y equals, I can put the 2 and the 4 together and get 6 minus 6x. Okay? And I'm going to divide everybody by 4. And I get y equals 3/2 minus oh, never mind. I was just looking at, never mind, it's not important. 3/2 minus 3x over 2, and that's our final answer, okay? I'll point out that because we're rearranging a lot of terms around, sometimes John's answers will have things written in a different order, right? Like we have our y term first and then the plain number. Here we have the plain number first and then we have the x. It doesn't matter which order these pieces are in, because remember that when we're adding or subtracting, this is technically subtracting, kind of, or adding a negative number, we don't even know anymore what we're doing. But you see my point. Order doesn't matter, right? 2 plus 1 is the same as 1 plus 2. That's how you can remember these crazy rules when you're in the heat of the battle. I do it a lot, you guys. If you're a little bit confused and not 100% sure on what you're saying, think up a simpler example. Like I just did. Does order matter when you're adding? I can't remember. Let's try it. 2 plus 1, 3. 1 plus 2, also 3. Doesn't matter, right? Just make up a little example for yourself. So if John wrote this as minus 3x over 2 plus 3 over 2, we would think carefully, did he put the minus sign with the right term? Yes, he did. Okay, then the order doesn't matter. So sometimes we have to interpret John's results, and that makes us feel smart. Guess what? We're halfway done with week 12. Oh my gosh, I'm very excited. Okay, that's all for now. Thank you, goodbye.